Hello everyone, welcome to TV Math. For those that are new to this channel, you are highly welcome. And my name is TV, your mathematics tutor at TV Math. I can be reached through this number here, or else you can send me a message via email, and that is at tvmathhub@gmail.com. At TV Math Hub, we help students simplify mathematics and improve their grades through clear lessons, revision discussions, standard paper analysis, and one-to-one assistance. So if you are struggling with mathematics or you want to boost your performance, don't worry, I've got you covered at an affordable cost. Simply send me a message via this number here, or send me an email and we shall get in touch. Today we shall continue our vectors series. We have already completed lesson 1 and lesson 2. And in case you missed those lessons, I will attach the link to the videos in the description for this same video. In our previous lesson, we stopped on this number here that was talking about the vector equation of the line that passes through the point A and is perpendicular to this line. So that is where we stopped, and we basically talked about a lot of things, but mainly we were looking at what we call the line. So we introduced what we call the line, whereby we said that the line can be defined in two ways. One is when you have a point that is lying on the line and a vector that is parallel to the line. We also looked at different forms of how we can define a line, that is the vector form, the parametric form, and what we call the Cartesian form. So we looked at those three different forms of how we can write the equation of the line. Today we shall be talking about the part B, that is how we can define an equation of the line, and that is when we have 2 points lying on the line. So we are saying, suppose the line passes through the points A and B, whose position vectors are A and B. That is vector A and vector B respectively. And then, if we have this line here, this is our line. So from A to B, this is the line that we are talking about. But on this line, we are having two defined points, that is A and point B, this one and this one. Now, on this same line, we are having a general point, which is a point R, which is a point R. Now, we want to look at for a general point that is R on the line. Then we can say that the line or the vector AB, we can say that vector AB and vector AR are actually parallel vectors. These are parallel vectors. So this is what majorly we want to talk about. You are having two defined points, A and B, which are lying on the line. This is the line that we are talking about. This one here is the line that we are talking about. But on this line, you have got 2 points, A and B, with these position vectors from the origin. Then we also have this point here, which is a general point, that is point R, with the position vector R. Now, I want us to look at these two vectors, that is vector AB and vector AR. As you can see, they are in the same direction. So it means vector AB and vector A to R are what we can call the parallel vectors, because after all, they are lying on the same line. Now, if a vector AB is parallel to vector AR, what we did in our previous lessons, we talked about parallel vectors, where we said if these two vectors are parallel, then one vector can be expressed in terms of the other vector. So meaning that I can have AB, if AB is parallel to AR, I can have vector AR is equal to lambda vector AB. That is what we can write, where our lambda is a constant or a given parameter. So where lambda is our constant value. So that is lambda is a constant value. Now, again, we are saying if AR is equal to lambda AB, but what is AR? AR is same as, in terms of position vectors, OR minus OA, which is equal to lambda. AB is same as OB minus OA. So if I have this, I can say this is OR, minus OA, which is equal to lambda into OB minus OA. Okay, that is the same statement. I want us to bring this one to the other side, such that I have OR is equal to OA, that is vector OA, plus lambda into OB minus OA. So looking at this one here is given by the position vector R. This is given by the position vector vector A. This is given by lambda. So this is vector B minus vector A. So in general, we shall be saying that the vector equation of a line that is passing through any two given points on the line is given by R, which is equal to A plus lambda AB. So this is how we define the line, that is the vector, a form for the line that is passing through 2 points A and B. So as you can see, the direction vector here is the displacement AB. When you compare this with when you are having 1 point on the line, if you recall, we said for 1 point on the line, R is equal to A plus lambda vector D. So where we were taking this D as our parallel vector. So you can have it as B. I think we are using B, not D. So yes, you can still maintain the B. So you say this one here is same as lambda vector B. So where B was our direction vector. A was a point on the line. Now for this case, the point on the line that we shall consider is point A. That is point A. And then the direction vector, the one that we had as B, will be the vector AB. So that is how we define the vector equation for the line when it is passing through 2 points. So that is what we shall be talking about. So we have this note that the position vector of any point on the line must satisfy the equation of the line. Though we have used vector A here, but still this equation here should be satisfied by vector B as well, because B is also lying on the same line. So in other words, using A, you can use A, you can use B, but the direction vector should be AB. That is vector AB. Then this A is a point on the line. Point on the line, you have 2 points. You can choose any of the 2 points. If you use A, then also someone who uses B, you should be able to get the vector equation of the line, and that vector equation should be satisfying, or should be satisfied by another vector that you might not have used. Then another thing is, customarily, the vector that is parallel, or what we call the direction vector, is usually in its simplest form, and the coefficient of I, if any, being positive. So you can get your, for example, AB, vector AB, which you are going to use as the direction vector. You can get this as 2, 4, and 6. If you get it like this, then you must, when you are using this AB, remember you are using that as your direction vector. That direction vector should be in its simplest form. So this one here, you can see that you can easily pull out the 2. You remain with 1, with 2, with 3. So when you are taking the direction vector, take the simplest form, and that is 1, 2, and 3. So you should be able to use this. In case you have your direction vector as negative 1, 2, and 3, it is important that you make this one here, this coefficient of I, this is in the position of I, you make it positive, meaning you can pull out negative 1, and you have this as 1, negative 2, and negative 3. So when you are taking your direction vector, you are taking this. So it is always important you take the one that is having a positive value for the I component. You take the one that is in the simplest form. So that is the most important thing here. So the vector that is parallel, or the parallel vector, or what we can call the direction vector, should be in its simplest form, and the coefficient of I, if it is there, should be what? Should be positive. Okay, so with that, let us look at some of the examples here. Our example here says that that find the vector equation of the line that is passing through the points A and B. You need to find the vector equation of the line passing through the points A and B. Okay, so with that, let us see how best we can get the vector equation of the line that is passing through these 2 points. As we have seen, we said that the moment you are looking at the vector equation for the line that is passing through 2 points, then we use R, which is equal to A plus lambda vector AB. So we use R, which is equal to vector A plus lambda vector AB. That is what we shall be using. With that, we shall be saying that our vector A, this one here, is 2, 5, and 1. That is our vector A. And now we need AB. So what will be a vector AB?
Vector OB minus vector.
So vector AB
OA
will be
vector OB minus OA.
Minus OA. So where our OB is given as 6, 7, and 9. And we have OA as
2, 5, 1.
2, 5, and 1. So this one will be equal to 6 minus 2.
4.
That is
8.
4.
2, 8.
That is 2.
8.
That is 8.
Yeah.
Okay, so that is our vector AB. But this vector, can it be simplified?
Yes.
We can simplify this. So we can have this as 2 into 2, 1,
1,
and 4. So when you are taking the vector parallel, or the parallel vector, our parallel vector will be, so the parallel vector equals, now you will take 2, 1, and 4. The one which is in the simplified form is the one that you take. Okay, so next we shall have to substitute within this equation. So this will imply that our vector R is same as we shall have
2, 5, 1.
That is vector A, 2, 5, 1. 2, 5, 1. And you add there lambda of 2, 1, and 2, 1, and 4. What is next after that?
You multiply vector AB.
We do what?
And you multiply the constant on the vector AB.
Yeah, let us come back to the question. The question says find the vector equation of the line passing through those points. Do you think you need to add there? That is the vector equation. The vector equation is of the form R is equal to A plus lambda AB. If you go on, what you will be getting is the parametric equation. So this one is the vector form, and that is where you stop. Okay? Yes. Okay. Yes. So this is the vector form. The moment you again compute and substitute for R equaling to X, Y, and Z, what you are getting now will be another form, which is the parametric form, and that will be wrong. So you will not have answered the question. You have gone past the answer. So if you go past the answer, it means you need to know exactly what you were doing. So can we look at the next one now? So question number 2 says, find the Cartesian equation of the line passing through these points. Should be now able to guide me there, all the steps. You just tell me so I can write. You are now the one explaining.
So we put the vector equation.
So which is which?
R.
From R, which is
equals to vector A.
Vector A
plus lambda AB.
Plus lambda AB.
Yes. So here you first find AB, which is you find it vector AB, which is vector OB minus vector OA, of which vector OB is 4, negative 2, 1, minus vector OA, position vector is 3, 0, negative 2. So vector AB equals to 1, negative 2, 3. Yes. So from there now, you plug in the value of A, which is 3, 0, negative 2, plus, then you plug in the plus lambda into, you plug in vector AB, which is 1, negative 2, 3. Yes. Then from there, you now multiply lambda and the vector AB to find the Cartesian equation.
Continue. We need the Cartesian equation.
Vector
What will be the next step?
You multiply the constant and the.
What is R? Will R remain like that?
No. Yeah.
You need to begin by substituting for R. What is R?
I thought you first multiply.
Okay.
You multiply the constant and the other values of vector AB, which is lambda, negative 2 lambda, and the 3 lambda. Yeah. Then from there, you add 3 plus lambda, negative 2 lambda, negative 2 plus 3 lambda. So for R, since it's 3-dimensional, we're going to substitute in x, y, z, which equals to 3 plus lambda, negative 2 lambda, negative 2 plus 3 lambda. And that becomes the Cartesian equation.
This one?
Yes. No.
You man. Who is safe? You haven't even got parametric equations. Remember, from vector equations, you got parametric equations, then you got Cartesian.
Then from there, now you equate. So it will be 3 plus lambda, which equals to, x equals to 3 plus lambda, y equals to negative 2 lambda, z equals to negative 2 plus 3 lambda. Yes.
So what is this?
Parametric.
These are parametric equations.
Yes. Then from there now, from there you are going to make lambda the subject. Yes. Then it will be lambda.
Lambda
Equals to x minus 3, and lambda also equals to negative 2 divided by y.
Negative 2 divided by y. Y divided by negative 2.
Okay, y divided by negative 2, which is negative y over 2.
No, maintain it like this. Maintain it the way it is.
Yeah.
Hey.
Negative. Okay. Then the other one is lambda equals to z plus 2 divided by 3. Yes. So since these are all values of lambda, you're going to equate them. So it will be x minus 3 equals to y divided by negative 2, which equals
What is happening there? Hey, I'm not getting you there. I don't know if there is. So from this given point here, whenever you have like x minus 3, make sure you put it over.
1.
This is over 1, such that you, when you are now to get the direction vector, person will easily see this is 1, negative 2, and 3. And another thing, right now like here, this is your direction vector. So it is always
I'm not here.
yes.
Your screen is not here.
Oh, okay, that be moved on. I think it is now okay.
Yeah.
Yes, I was saying that now your direction vector is this 1, negative 2, 3. So whenever you are giving the Cartesian equation, maintain it. Maintain 1 here, negative 2 there, and 3 there. Because as we shall always be seeing is that these values, the coefficients for x, y, and z, always, it must be 1 and also positive, okay?
Yes.
Yes, the coefficients for any standard equation, the coefficient should be, the coefficient of x, y, and z should be positive 1. So in any case, you get an equation of this nature. For example, you have negative x plus 3 divided by 1 is equal to maybe y divided by 3, y minus 2 is equal to maybe 2z. Okay, let me maintain, okay, 2z plus 4 divided by 2. So when you are taking the direction vector here, you need to be careful. Now you can see, for example, the coefficient of x here is not what? Is not 1. When you look at this, this is 2, not 1. So what you do, you first rearrange it. Because the coefficient of x, y, and z should be positive 1. So to do that one, what do you do here? You pull out the negative to make it positive over 1 is equal to y minus 2 divided by 3 is equal to, now pull out that 2 such that this becomes z plus 2 over 2. Then this one now will affect this one such that you have x. Okay, this should be minus, not a positive, because I've pulled out that negative 1. So it should be x minus 3. So this should be x minus 3 divided by negative 1. Y minus 2 divided by 3. This and this will cancel. You get z plus 2 divided by 1. So now the direction vector here, the direction vector is this one, negative 1, 3, and positive 1. So by all means, make sure that the coefficients for x, y, and z is what? Is 1. For you to say that what you have down here is the direction vector. And as we have said,
Okay.
two things are important when you are talking about the line. One, you must know the direction vector, and two, you must know the point that lies on the line. For example, if I give you this equation here, the Cartesian equation, what will be the point on that line?
Y.
The point on the line is obtained by equating this one to what? When I equate x
Oh,
minus 3 to 0, I get 3.
3.
This one I get 2.
Mm,
This one I get
negative
negative.
2.
So this is the point on that line. The direction vector is this one, which is in the denominator. Negative 1, negative 1, 3, and 1. Then now, like for this one here, if someone asks you what is the point on this line, what is the point on this line?
Mm.
The point on this line is what?
Point is Y.
This one, as I said, you equate this to 0. Y, of course, this is y plus 0. Z, the point for Z will be this Z plus 2 equaling to 0. So the point is 3. When you equate this to 0, it remains 0. When you equate this to 0, it becomes negative 2, which was the given point of A, which was 3, 0, negative 2. So when you have the Cartesian equation, you can easily get the point on the line. You can easily get the direction vector to the line.
Okay.
Yes.
So these ones must relate to the ones in the equation.
Yes. This one relates to the ones that you have used. This one here. Because sometimes they can give you the equation and they want you to just extract out the direction vector and the point that is on the line. So you must be knowing how do I get the point on the line? How do I get the direction vector? Because as we move on, we shall see you are given two lines. They want the angle between the two lines. You will not be using it the way it is here. You will simply be looking for the direction vector. So you must know, how do I extract out the direction vector? How do I extract out the point on the line?
Okay.
The point on the line, as I said, you equate these ones, the numerator to 0. X minus 3 equaling to 0, you get the x coordinate. Y is equal to 0, you get this one. Z plus 2 equaling to 0, you get the z coordinate. Then the direction vector, before you get it, you say that 1, negative 2, 3 is a direction vector. You must be careful. You must check and see what is the coefficient of x here, coefficient of y here, coefficient of z. As you can see from this example, if you take your direction vectors 1, 3, and 2, that will be wrong. The direction vector must be obtained only when the coefficients for x, y, and z are equal to what? Are equal to 1. Like the way we have first manipulated it here. So you can see the coefficient of x is 1, coefficient of y is 1, coefficient of z is 1. So from there, what you remain with in the denominator here is actually the what? Is actually the direction vector. I hope that one is understood.
Yes.
So let us look at the next question. Find the Cartesian equation of the line that is passing through the points A and B, whose position vectors are, we have those ones there. What will this one be equal to?
But sir, I have a question.
Yes.
When do you know, when do you use the first vector equation and the second one?
Now, like which one? Right from here.
Like R equals to A plus lambda B only.
When do we use this?
Yes.
And when do we use this one? R is equal to vector A plus lambda B.
Yes.
This B, we were taking it as the direction vector. And if you recall very well, for that case, we were given two things. One, you were having a point on the line, and two, you were having a vector that is parallel to the line. So the equation that we had here of lambda is equal to, let me summarize it here. In the first case, remember we said that a line can be defined in two ways. The first one was when we had a point on the line. You have a point on the line, but you also have a vector parallel to the line. A vector parallel to the line. That is the first way how we can define a line. And this way we had something like this. You have a line, but on this line you have a point A. You have another general point R. Then you are defining these from a given origin O. So this was having point R, this was having point A. That is the vector A, position vector A. And then this is our AR, but this is the line we are talking about. But along this line, we had a vector that is parallel to that line, which is vector what? Vector B. So this was a vector that is parallel to the line. So if you have a point on the line, you have a vector parallel to the line, you use R, which is equal to vector A plus lambda vector B. B is representing the direction vector. So here you are having only one point, but you also have a vector that is parallel to the line. You use this. 2, that is the first way, okay? Is that one okay?
Yes.
Now the second way how we can define a line is you have 2 points on the line. You have 2 points on the line. Now, when you have 2 points on the line like A and B, then your R will be vector A plus now the vector that is parallel to the line is obtained by getting the displacement AB. Instead of having this one here, instead of having this, the vector that is parallel to the line, in its position, we are having that vector as the displacement AB. So here you are having only 1 point, just a point, but here you have 2 points. So if you have a point, you have a vector that is parallel to the line, you can simply use this. But then if you have 2 points on the line, like A and B, then the direction vector will be the displacement AB. And that is when you use this. Now, whenever you are going to define a line, there are 2 important things that you must have. One, you must have 1 point, at least 1 point on the line. And 2, you must have what we call the direction vector. If you have only 1 point, then you must be having the direction vector to define, because you cannot define line or you cannot get line when you have only 1 point and you don't have the direction vector. So it means if you have 1 point on the line and the direction vector, you simply substitute in this. But if you have, or if your line is passing through 2 points like A and B, then you simply use 1 point like use the vector A, then the direction vector that they would have given you, you will now obtain it by getting the displacement AB. So that is how we define a line. So a line is defined by these 2, a point on the line and when you have 2 points on the line. So the one we did previously, in our previous lesson, was this. A point on the line, you have a point on the line, but you also have a vector that is parallel to the what? That is parallel to the line. Then, but for this case, we are looking at the second way how we can define a line. And that is when you have 2 points on the line, now you can also get the direction vector, which is the vector AB. So that is how we distinguish those 2. So we want to also look at this. You want the Cartesian equation of the line that is passing through the points A and B. Whose position vectors are those? That is I plus 2j minus 5k, then that one there. So can I assume that you will be in position to do that one?
Yes.
So I will leave it for you as a trial question.
Okay.
Okay, because you are. Let us look at this note. It says in a situation where 3 points lying on a line are given, such as A, B, and C, then the vector equation of the line is given as that. So we are looking at a situation where we have 3 points lying on the line. The most important word here is the 3 points are lying on a line, meaning that A, B, and C are collinear. A, B, and C are collinear. And if they are collinear, then we can say that vector R is equal to vector A plus C lambda BC. Or else you can get the vector equation as R, which is equal to vector A plus lambda AB. So you can as well get that. So you can use this or you can use that one there. Now from these relations, these ones will hold, or you will be able to say that A, B, and C lie on that line there if A, B, and C are collinear. Otherwise, this one will not hold for all the points. So this one here is very important. 3 points must be lying on a line for you to conclude that vector R is equal to vector A plus C lambda vector AB, or to use this given expression. We can look at this example. It says, the example says, find the Cartesian equation of the line passing through this point B and C. So let us see a solution to that. Now, since these are 3 points, we must first of all test whether the points are collinear. So let us test for collinearity. Let us test for collinearity. Then if they are collinear, we can go on and put R equaling to vector A plus lambda vector BC. So let us look at that. So we need to test whether the 3 points are collinear. So let us check that. Let us check whether A, which is 1, 2, 5, B, which is 2, 1, 0, and C, which is 5, 3, and 2 are collinear. We need to check whether these are collinear. And if they are collinear, then AB should be expressed in terms of BC. If they are collinear, AB should be expressed in terms of BC. This is what we need to check. Now let us get AB. Vector AB is same as OB minus OA. So what is OB? OB is 2, 1, 0. This is 1, 2, and 5, giving us this is 1, this is negative 1, this is negative 5. So this is A, B. Then we need to look at BC. So vector BC is OC minus OB. So what is vector OC? OC is 5, 3, 2, 5, 3, 2. OB vector OB is 2, 1, 0. 2, 1, and 0. 2, 1, and 0. So that will give us 5, 3, 2, 2, 1, 0. This will give us 3. This is 3. This is 2. This is 2. So can we have AB in terms of BC? Is it possible to express AB in terms of BC? So for AB equaling to lambda BC, what shall we have? AB equaling to lambda BC. So looking at that, we shall have AB as 1, negative 1, 5, negative 5. This is lambda into 3, 2, and 2. So it is clear here, this is 3 lambda equaling to 1, so lambda is a third. Lambda is negative 2 over 3. Lambda is negative. Okay. This one is not. So this should be. So this is negative a half, not that. So lambda here, this one negative 1 is equal to lambda negative a half. So lastly, lambda is negative 5 over 2. So you can easily see that AB cannot be expressed in terms of BC. So looking at these values for lambda, we can easily conclude that since lambda values are not constant, then AB cannot be expressed in terms of BC. So since lambda values are not constant, then AB cannot be expressed in terms of BC. AB cannot be expressed in terms of BC. And if that is the case, then it means thus the points are not collinear. And if the points are not collinear, we can now give the conclusion that therefore there is no single straight line. There is no single straight line that passes through the given points. Hence, the Cartesian equation of a line passing through all the 3 points does not exist. So that is how we shall show that the Cartesian equation of the line passing through this point does not exist. So you must check whether A, B, and C are collinear. And if they are collinear, then go on and put for R equaling to vector A plus lambda vector BC. and get the Cartesian equation. But in case the points given are not collinear, then it means there is no single straight line that passes through the given points, and hence the Cartesian equation of the line passing through all the points does not exist. And that is how we do that. So hoping that that one is okay, then we shall go on and look at another question. So let us look at example number 2. It says the position vectors of points A, B, and C are, we have this one representing A, representing B, and this representing C. We need to find the Cartesian equation of the line passing through A, B, and C. So to obtain that, one, we know that the Cartesian equation of the line passing through 3 points is given by that. So what we need to first do is to first see whether all these points here, A, B, and C, lie on a straight line. In other words, we must first of all test whether they are collinear. So now what we shall do is, let us first look at A to B. What is AB? AB is OB minus OA. So vector AB is OB minus OA. But what is OB? OB is 3, 4, and 5. What is OA? That is 2, 1, and 3. So this will give us 1, 3, and 2. That will give us 1, 3, and that will give us 1, 3, and 2. So let us also look at BC. So what will be B to C? So BC is same as OC minus OA. So, but what is OC? OC is this one here, 6, 13, 11, 6, 13, and 11. We are subtracting OA. Oh, BC, this should be, we are subtracting OB. So OB is 3, 4, and 5. 3, 4, and 5. So this will give us, this is 3, this is 9, and this is 6. So, but when you look at this, this will be 3 into 1, 3, and 2. So it is clear, that BC can be expressed in terms of AB. So it means that A, B, and C, A, B, and C are collinear. In other words, they all lie on the same straight line. So if that is the case, now you can obtain the vector equation using R is equal to A plus lambda BC. So our R will be equal to A. So what is point A? 2, 1, 3. Point A is 2, 1, 3. So this will be 2, 1, 3. So add there lambda BC. BC is equal to this, which is equal to this. But whenever we are taking the direction vector, we take the simplified form. So it means we shall take the simplified expression, that is 1, 3, 2. So we shall take 1, 3, 2, the simplified expression. So this will give us, let us substitute for R. So substitute for R, vector R, which is X, Y, Z. So here we are saying we are taking the parallel vector for BC. BC is our parallel vector. So our parallel vector is the simplified expression of BC. So our parallel vector is the 1, 3, 2. This simplified expression, this one here. So this is what we take as our parallel vector. So from that, substituting for R, we shall have this as X, Y, and Z. So this is equal to, now put your A, that is 2, 1, 3, then a plus lambda into 1, 3, and 2. So this implies that X, Y, and Z will be equal to, this is 2 plus lambda, 1 plus lambda, 3 lambda, 1 plus 3 lambda, then 3 plus 2 lambda. So this will imply that our lambda will be X minus 2, of course, divided by 1. Lambda will be y minus 1 divided by 3. Z will be, okay, not Z, lambda will be, let me have it here, lambda will be Z minus 3 divided by 2. So this implies that our Cartesian equation will be x minus 2 divided by 1, which is equal to y minus 1 divided by 3, which is equal to z minus 3 divided by 2. So this is the Cartesian equation of the line. We need to look at another part there. We need to look at to show that a given point lies on a line. How do we show that a given point lies on a line? That is what we want to look at. So we want to suppose, I want us to suppose that this point here, ABC, lies on the line x minus x naught over x1 equaling to y minus y naught over y1 equaling to z minus z naught over z1. And then what happens? Then when we substitute this point into the equation, we obtain a constant value. We obtain a constant value for the values of A, B, and C. What does this imply? If you are given an equation of the line, I hope at the moment you can easily tell me the point on this line and the direction vector of this line. What is the point on this line? This is the Cartesian equation of the line. What is the point on this line? And what is the direction vector? What is the point on this line?
Yeah, the point is x naught, y naught, and z naught.
Okay, that is okay. Then the direction vector?
Direction vector is 1, 1, 1.
1, 1, 1. From where?
It is x1, I mean, x1, y1, and z1.
It is x1, y1, and z1. Now, we want to show that a point, this given point here, A, B, C, lies on this line. So in order to show that this point lies on this line, what we shall do is, where there is x, y, and z, we shall be substituting there A, B, and C. Remember, x, y, and z represents a general point on the line. But for our case now, the point is A, B, and C. So you will be substituting for A, where there is x, you put A, where there is y, you put B, where there is z, you put C. If these ones are able to give you a constant value for lambda, then we shall say that the values A, B, and C satisfy that line. And for that case, it means the point ABC is a point on the line. We can understand this better by looking at some examples. So let us talk about some of the examples. So example number 1 says, show that a point with coordinates 4, -1, and 2. This is 12, 4, -1, and 12 lies on the line. And the line we are given is R, which is 2I plus 3J plus 4K plus lambda into I minus 2J plus 4K. So that is what we want to look at. We want to show that this given point here lies on this line. So if it lies on this line, it must be in position to satisfy the equation of the line. So that is what we shall look at. So generally, we are given generally we are given R, which is equal to, let me put it in column form. This is 2, 3, and 4, plus lambda into, this is 1, -2, and 4. So that is generally what we are given. But now we want to show that this point here lies on this line. Now, when you substitute for R, let's substitute for R. Remember, R is X, Y, and Z. So X, Y, and Z will be equal to 2, 3, 4 plus lambda into 1, -2, and 4. So what we shall do now, we want to show that this is a point which lies on this line. So to do that, we shall now substitute where there is X, Y, and Z, we put that point. So substitute for X, Y, and Z. Substitute it with the given point. So the given point is 4, -1, and 4, -1, and 12. So where there is X, Y, and Z, put this point. So when you put that point, what we have? We shall have 4, -1, and 12, which is equal to 2, 3, and 4, plus lambda into 1, -2, and 4. Now, with that, get the value of lambda. If lambda is the same throughout, then we shall substitute. We shall say that that point lies on the line. If lambda is different or is not consistent, then we shall say the point does not lie on the line. Okay, so let us try to simplify that. I want to bring this one this side. So I will have 4 minus 2. I will have -1 minus 3. I will have 12 minus C. I hope this is okay. I've brought this one the other side.
Yes.
This is equal to lambda into 1, -2, and 4. So what will this one give us? This will give us 2, -4, and 8, which is equal to lambda into 1, -2, and 4. So when you multiply lambda here, this will be lambda, -2 lambda, and 4 lambda. Now equate this with this. What does this one imply? This implies that 2 is equal to lambda, and therefore lambda is equal to 2. -4 is equal to -2 lambda, this one and this, which implies that lambda is 2. 8 is equal to 4 lambda, which also implies that lambda is equal to 2. So since the values for lambda are consistent, therefore the point lies on the what? On the line. So that would be our conclusion. That since the value of lambda is consistent, we can also use the word constant. Is the same. Is constant. Is constant. Therefore, the point lies on the line. So if the point does not lie on the line, you will have like lambda is 2, lambda is 3. You will get different values of lambda. But if lambda is the same or is constant, then we conclude that that point lies on that line. So that is how we show that a given point lies on a line. So if a point lies on the line, then the point must be satisfying the equation of the line. So you simply put it where there is R. So put it there and simplify, get the values for lambda, and from there you conclude basing on the values of lambda. So that is our example 1. And if it is okay, we can look at another example.
Yeah.
So another example says, example 2 says that show that a point with position vector I minus 9j plus k lies on the line, which is given as 3i plus 3j minus vector k plus lambda into I plus 6j minus vector k. This one is also your try question. Please make sure you try those questions and send me. I haven't seen any work from you as also part of those ones to be shared. So we can put another example, that is example 3. So example 3 says A and B are the points. A and B are the points 3, 1, 1 and 5, 2, 3 respectively. And C is a point on the line R, which is equal to 2 plus 2 lambda I 4 minus lambda j plus negative 2 plus lambda into k if angle BAC equals 90 degrees. Find the coordinates of C. So we are having that question there. A, B are the points, this and this, 3, 1, 1, 5, 2, 3. And C is a point on the line, which is given here. 2 plus 2 lambda I, 4 minus lambda j, minus 2 plus lambda k. Then we are given that the angle BAC is 90 degrees. We need to find the coordinates of C. So let us look at the solution. When we look at this question here, 1, we are told that point C is on this line. So we can do some simple illustration. So we can do some simple illustration to understand this one better. So we are dealing with X, Y, and Z plane. So that is X, Y, and Z plane. So we are dealing with 3D. So we can have that. So this is our Z. This is our X. This is our Y. Now we are having a line. This line here is the line, maybe let me call this our line L. This is the line we are having. This is the line R. Okay. So this is the line, but we are told that C is a point on this line. So can I have maybe point C here? C is a point on this line. So if C is a point on the line, we are having a point A and a point B. So we can locate point A and B anywhere. So let me have this as maybe B and have somewhere here A. So I'm having something like this. I'm having something like this. Okay. We are told that the angle which is here is 90 degrees. So this is where A is. C is a point on the line. And this angle at B, at A, because that is BAC. BAC. The angle at A is 90 degrees. So that is what we are basically having. But what do we need? We need C. And what is C? C is a point on the what? C is a point on the line. So if C is a point on the line, let me have my point C. You can have it as any point. Maybe and I rate it to be AB, AB, A, B, and C. I hope it will not confuse you with this. It might confuse us with that one there. Let us leave it as point C. Okay. Now, since we are told that C lies on the line, then C satisfies the equation of the what? The equation of the line. So if C satisfies the equation of the line, then what does that one mean? So we are told that C is a point on this line. So we can say since C lies on the given line, since C lies on the given line, then C satisfies the equation of the line, isn't it? So, but what is the line? So from the line, R is equal to, so we have R here, 2 plus 2 lambda I. So that is 2 plus 2 lambda I. 2 plus 2 lambda, this is in I, so that is in this position. Now I'm putting it in the column form, then 4 minus lambda. So we have 4 minus lambda here.
Yes.
Then next we have negative 2 plus lambda. So next we have negative 2 plus lambda. So that's why it was written. Now this time they have not split it to be like 2i plus 4i plus 4j minus 2k, then plus lambda into. They have not split it, so they have given it in this form. But you can also put it in the other line form that we know. Now you can split 2, 4, negative 2 plus. Now you put the lambda out, you get the direction vector. Okay, but let us look at that. We have our vector R as this. So if C lies on the line, remember what we said. Remember what we said? I wanted us to let this one here. Maybe it can become easier. So can I have it as A prime, B prime, and C prime? Or we can use any other values. Which other values are suitable? P, Q, and R? You can choose any values which are suitable for you. Which values are suitable?
Yeah, we can use any.
We can use this. Is this one okay? A prime. I don't want, because when you say A, you can take it
This one is okay.
as this one. That one is okay. Okay. So A prime. Now we are saying since C lies on the given line, from what we did here, we said if a point lies on a line, then that point there, like this, if 4, negative 1, 12 lies on this line, what do you do? Where there is X, Y, and Z, you put this, isn't it? So the same applies to this. We are saying this point C lies on the line. But what is point C? Point C is A prime, B prime, and C prime, isn't it? But we are letting this one A prime to be the X coordinate, B prime the Y coordinate, C prime the Z coordinate. Now, if C lies on the line, then C satisfies this point. So from the line, we can say that X, Y, and Z is equal to 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. Now, CC, which is A prime, B prime, C prime, lies on the line, then can we say that where there is X, Y, and Z, then we can substitute X, Y, and Z with A prime, B prime, and C prime. Is that one okay?
Yes.
The same way we did
Yes.
our previous example. We said if 4, negative 1, 12 lies on the line, then you substitute where there is X, Y, Z with this. That is what we did.
Okay.
So that is again the same thing we are doing, because C lies on the line. Then C must satisfy the equation of the line. So where there is X, Y, and Z here, we shall put there A prime, B prime, C prime. So this is equal to 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. I hope that is okay.
Yes.
Okay. So that will be the A prime will be equal to that, B prime will be equal to that, C prime equal to that. But of course, this is pointy. This is our point C, the one which we have substituted here. So this is our point like OC, the one we are substituting. Because C is equal to this, which is equal to that. Now, from this, what else are we given here? We are again told that the angle BAC is 90 degrees. If this angle is 90 degrees, what does it imply? From the vectors that we have studied, what do you say if this one is 90 degrees? What does that one imply?
The dot product is 0.
Of which one?
Dot product of AB and AC.
A, B, and BC? How?
A, B, and AC.
A, B, and
AC.
A, B, and AC. Because the 90 is at the A. So the 90 is at the A, it means when you get AC, you dot it with AB, you get a what?
0.
You get a 0. So again, that is the idea we shall use. We shall say, but since AC is perpendicular to AB, then what should be our conclusion? Then
Then
AC dot
AB
is
equals to 0.
equal to 0. Okay. Remember, we need the point C, and point C is A prime, B prime, C prime, which is equal to this. 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. Meaning that to get the vector OC, I must know what?
Lambda.
I must know lambda, because OC is equal to this. Now, can we go on and get AC, because we are given this? This is the fact we are getting from this. Because if this is 90 degrees, then AC and AB, their dot product is 0. Now, I want us to get AC. What will be AC? We have point A. We have point A, 311. So get for me those. Point A is 311. A is 311. B is 523. Is 523. 5, 2, and 3. So what will be AC? AC is, let us get AC. AC is OC minus OA.
523 minus 311.
Hey, which one are you getting? We are getting AC first.
511.
AC. This is B. C is here. This is the C, this one. OC is equal to this, which is equal to this. So where there is OC, we shall put there 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. But we are subtracting OA, which is 311, which will be same as 2 plus 2 lambda minus 3. So 2 minus 3 is
lambda.
That is it.
2 lambda. 2 lambda.
Minus 1.
Minus 1.
Because we get 2 minus 3, which will be that. This one.
Negative lambda.
Negative lambda. 4 minus 1.
3.
3.
Plus 3.
This one. Negative 2.
Lambda.
This is lambda. Plus 3.
Yes.
Plus 3 minus 3. This is negative 2.
Minus.
Negative 2 minus 1. Negative 3.
3.
So this is our AC. Then we need AB. That is OB minus OA. OB is 5, 2, 3.
3.
OA is 3, 1, 1. Is it?
Yeah.
Giving us
2, 2, 1, 2.
This is AC, this is AB. But what do we need? AC dot AB. Okay? We need to get this. We have AC, we want to substitute this. We have AC, we have AB. So can we dot the two? So from AC dot AB equaling to 0, it will imply what is AC. We have got our AC here. Our AC is 2 lambda minus 1, negative lambda plus 3, lambda minus 3. That is AC. So that is 2 lambda minus 1, negative lambda plus 3, and lambda minus 3. I hope I have picked the correct ones. 2 lambda minus 1, negative lambda plus 3, lambda minus 3. We are dotting this with 2, 1, 2, AB. And we are getting this as 0. So now dot. So that will be 2 into 2 lambda minus 1 plus 1 into negative lambda plus 3 plus 2 into lambda minus 3, which is equal to 0. So this is 4 lambda minus 2 This is minus lambda plus 3 plus 2 lambda minus 6, which is equal to 0. I hope you are still following.
Yes.
So this will be 4 lambda minus lambda, which is 3 lambda, plus that 5
lambda.
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 Negative 2 plus 3,
1.
1 plus
Yes.
negative 6,
Negative 5.
negative 5 is equal to 0. So 5 lambda is equal to 5, and lambda is
1.
and lambda is 1. After getting that, next, what do we need, by the way? You should not forget what we need. We need the coordinates of
C.
C. And what are the coordinates of C?
2 plus 2 lambda.
Plus 2
4
lambda,
minus
4
lambda.
minus lambda, negative 2 plus lambda.
Plus lambda.
So can we now substitute?
Yeah.
So for OC, which we saw as vector A prime, B prime, C prime, it will be equal to, now, it was 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. So this was 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. We are not dotting. We are substituting for lambda. Let me confirm. 2 plus 2 lambda, 4 minus lambda, negative 2 plus lambda. Okay. So now let us substitute for lambda equaling to 1. So for lambda equaling to 1, we shall have OC as, so it was our A prime, B prime, C prime, which is equal to 2 plus 2 times 1, 4 minus 1, negative 2 plus 1. So this will be same as 4, 3, negative 1. So this implies that we needed the coordinates of C. So this implies that C the point C will be in coordinate form 4, 3, negative 1. And that will be the answer. Is that one okay?
Yes.
So the main or important thing here that you were given is you are combining 2 points. One, this point C is a point on the line. You must recall that a point on the line must satisfy that given line. Then you are given this condition, BAC is 90 degrees. So if you are given 90 degrees at the A, then it means A to C, A to B are perpendicular. And for that case, you should be able to get or to use that expression there. Or you should be able to recall about the perpendicular vectors, such that you are in a position to get the value of lambda, which will help you to get the value for the point C. You will try for me these questions here as well. You will try for me this first one. Is saying the Cartesian equation of a line You have this question here. You will tell me what will be the parallel vector to this line? Be thinking about that. Parallel vector of that line. You can write it for me somewhere and you will tell me. And actually the point on that line. Are you done with this one? The first question here, I want you to tell me what will be the vector that is parallel to this line?
So my network was glitching.
Hey.
Yeah.
So I want you to tell for part 1. This is the question 1.
Okay.
Which you will try out. So you need to get the vector and parametric equations of this line. So how do you get that?
You first you equate them to the constant lambda.
Yeah. You will. So actually, it is like you are starting from the Cartesian. You are coming back to the vector equation. So you are going backwards, eh?
Yes.
So what you do, you equate these ones to lambda, and now I get the parametric equations. Then after getting parametric equations, get the what? I get the vector equation.
Yes.
But when you are given this one alone, what will be the parallel vector?
Which one?
You are given this Cartesian equation, and I want you to extract for me the parallel vector. What will it be? So put it down and try to manipulate it. Then you let me know.
Okay.
So
Is it the parallel vector?
I need the parallel vector or the direction vector.
Okay.
Hey. You have x minus 3 over 2, 2 minus y over 5, 2z minus 3 over 4. Get for me the direction vector.
Okay.
You have put it down?
Yes.
Okay. Manipulate that as I put the last question. So I hope my screen is visible there. So that was our question 1, the Cartesian equation of the line.
Yes.
Is my screen clear? So we wanted to get the vector equation, the parametric equations. So these are parametric equations. So you have x minus 3, so that is x plus 3. Okay, so y minus, okay. So this is okay. So this is also okay. You don't write the vector equation in this form. So this is wrong here. So the vector, this is a coordinating form. Vectors are written if you are looking at the position vector. So I expected you to leave this one as r, which is equal to 3, 2, 3 plus lambda into 2, negative 5, and 2.
Okay.
Don't put it in this form. A vector is written, if you are writing a vector in vector form, make sure you write it. If you are to write it this way, it should be 3i plus 2j plus 3k. Then plus lambda is 2i minus 5j plus 2k. Leave it in this form or put it in this form. Don't put it in this form here. This is not
Okay.
the vector form.
Okay.
Mm. Uh-huh. So that C with position vectorized on this line. Uh-huh. Since the value of lambda is constant, the point, that one. So that should be the point with a position vector. If you are writing a point on its own, you write it as 1, negative 9, and 1. But you should have this a point with position vector. It is the vector that we write in this format. But when you simply say the point, this one, this cannot be a point. This is a vector. A point, you either use this, or you can say the point with position vector, this lies on the line. So this is okay. And the procedure here is okay. Hey, they are only two.
Yes.
But there were many questions. How comes there are two?
No, that was I tell you. I was doing some work, so I could not finish.
You finish, you finish. Okay, so let's look at something else. So yesterday we were looking at the Cartesian equation of the line that passes through 3 points. We looked at how to show that a given point lies on a line. Then we also okay. So we also talked about how best you can show that a given point lies on the line, and that is where we stopped. So today we want to look at something else, and that is how to get the distance of a point from the line. So we want to talk about the shortest distance of a point from a line. This is what we want to talk about. So when we are looking at the shortest distance from a line to the point, then here we shall be looking at the length of the perpendicular line segment that is between the line and the given point. So here we shall be saying that we are interested in obtaining the shortest distance of a point from a line. And this shortest distance of a point from the line is actually the length of the perpendicular line segment that is between the line and the given point. For example, let us consider this. If we consider some line, let us first consider our plane here, which is in the 3D. So here we have our X, we have our Y, we have our Z. Now this is our origin. Now I want us to consider a line. This is the line, and on this line, I want us to consider 2 points. One point that is a point A, and another point which is point T. I want us to consider these with position vectors. That is position vector A, and this one here with position vector these are straight lines, so with position vector T. Now I want us also to have another point. So these are 2 points that are defined on this line here, and I want us also to have what we call the parallel vector B. Now if we have 2 points A and T defined by the position vectors A and T respectively, I want us to consider another point which is a point P. This is a point P which is also defined from the origin by the position vector P. Now we are interested in obtaining the shortest distance of a point from the line. Now this is our line, this one here is our line, and these are 2 points on the line. That is, we have a point A, we also have a point T. Now I want us to obtain the shortest distance from this line to a point P, and from this line, this point P, when we extend this line here, when we extend this line here coming from the line, so that is the point that is meeting the line, and we are interested in this distance here, which is distance D. We are interested in the distance D. That is the distance from the point P to the line, because this is our line. And this point P, the line from point P meets this line at a point which we are calling T, that is defined by the position vector T. So that is what we want to consider. Now, with that, we are interested in how best we can get this distance here. This is the point, and this is the line, and we are interested in this distance from the line to the point. And we are saying that when you extend this line from this perpendicular line segment from point P, it meets this line here at a given point, which we are calling point T, which is also defined. Now, I want us to look at how best we can obtain this distance D. We shall be following a few procedures to get that. The first one, so let us say to obtain the shortest distance, distance of a point P, from the line. Let's say this line is of the form A plus lambda vector B. Okay, we are taking the line to be of this form, that is the vector form of this line. B is the parallel vector, A is the point that we are considering. Now, from this given point P to the line, we are interested in this distance. So we shall be following some few steps. So the following steps shall be considered. So what are those steps? The first one, we shall first of all let the perpendicular this line here from point P to meet the line at a point T. So we shall say that let the perpendicular from point P meet the line at point T. Then the next one, we shall say, what we are saying is, we are interested in this distance. So we are saying that let this distance here, the line from P, meet point T, which T is a point on this line. We are again saying, next, you will obtain the vector PT in terms of lambda. You will obtain a vector PT in terms of lambda. Then next, when we do that, but I hope before we come there, you still recall that if T is a point which is on this line, then it satisfies this equation of the line. So that's why we are saying you will substitute and obtain the vector PT in terms of lambda. Then after doing that, you will obtain the value of lambda. The next procedure will be to obtain the value of lambda. Obtain the value of lambda for the point T, using the fact that when we look at this line here, this line segment P to T is perpendicular to this line. So you are having something like this. This is your point P. It is perpendicular to this line, but this line is parallel to B. What does that imply? If this is point T, it implies that vector PT and this B, since this one here is perpendicular to the line. If it is perpendicular to the line, then what happens? It means also the vector PP is perpendicular to the direction of vector B, because this vector B is parallel to the line. So that is the fact that we shall use, that PT, when you dot it with B, you get a what? You get a 0. Now, that is the fact we shall use, that PT dot vector B is equal to 0. Now, after using that fact, you will be able to get the value of lambda and the required distance. Will be D, which is equal to magnitude of PT. The distance you are looking for is this distance from P to T. So it means if I know PT, vector PT, I can easily obtain the value of D. So those are the few procedures we shall be considering when we are looking at the shortest distance of a point from a line. That is a very common question. So you need to make sure you understand how we obtain this. But it's very simple. We shall look at the examples so we can understand that one better. So let us look at some examples unless you have a question.
No.
Okay, so let us look at the examples. Number one, it says, find the perpendicular distance from the point which is B 1, 1, 3 to the line. And what is the line? X plus 4 over 2, which is equal to y plus 1 over 3, which is equal to z minus 1 over 3. This is what we need to look at. Now, to look at this, we shall do some simple sketch. What are we given? We are having, this is the line. We are having our point and a line. So let me have this as my line. This is my line. But this line has got a parallel vector, or the vector that is parallel to this line. Which vector is it? Vector B, which we are calling vector B. Now, I want to consider a point. This point is the point B, 1, 1, 3. This point here, I want the distance of this point from this line. So I will create that line there. I want this point B, the line from point B, to meet this line here at a point T. So this is our line. This is our point B. So we need this perpendicular distance, which I can call D. We need that distance. So if I'm interested in this distance D, what should I know first? I must know the vector B to what? B to T, isn't it? Then if I know the vector B to T, then I will be able to get the distance by getting the magnitude of B to T. So my interest is getting B to T. And when I get B to T, I will obtain that distance by simply taking the magnitude. That is what we need. Now, if T is a point that lies on this line, what does that one imply? It implies that T satisfies the equation of the what? The equation of the line. Yesterday we talked about that. We even looked at some of the examples where you are given a point and they want you to show whether that point lies on a given line. So it means that the point must satisfy the equation of that line. So similarly, if T is a point on this line, then T must satisfy the equation of the line. So that is what it means. Now, can we look at this now? We shall be saying that T is a point. T is a point at which the perpendicular from B meets the line. So we are saying this T is a point on the line from which the perpendicular from B, this line from B, this perpendicular line segment from B meets this line here. So this perpendicular line segment meets this line at a point what? At a point T. That is what we are saying. Now from that given information again, we shall again say, let us first of all express the line that is given in the vector form, because we are given the Cartesian form. So we are given the Cartesian form, so let us first put it in the vector form. So let us express the line in the vector form. Now, what we are given here is x plus 4 over 2 is equal to y plus 1 over 3, which is equal to z minus 1. So if you are given that, Remember, you are given x plus 4 over 2, y plus 1 over 3, z minus 1 over 3. So I hope at the moment you know how to obtain this one here in a vector form. I don't want to go through all the process that you went through here, where it was this one here. So we want this one here. We want this, but we don't want to follow all this process of doing this, because otherwise that would be wastage of time. So what we shall do is, the first thing you know is we shall have the x, y, and z, which is equal to, what is the point on this line? The point on that line first. This one should now be easier for you. What is the point on this line?
-4,
Negative 4, negative 1, and
1.
Then plus lambda, what is the direction vector?
2, 3, 3.
2, 3, 3. So clearly, it implies your R is same as negative 4, negative 1, 1, a point on the line, plus lambda into the direction vector 2, 3, and 3. 2, 3, and 3. Okay? So this will be the vector equation. You can easily get it just in one line. So you don't need to first rate this one equal to lambda, then you get x is equal to, this one can easily be seen because this side you have x, y, and z. What you put here will be this equated to 0. When you equate this to 0, when you equate this to 0, when you equate this to 0, you get the point on the line. And then what is here in lambda as the coefficient will be 2, 3, and 3. So that one you can easily get. Now this is the vector equation of the line. Now if this is the vector equation of the line, let us see what will be a vector that is representing t. Remember, t is a point on the line. So if t is a point on the line, at point t, it means the position vector of t will be satisfying this equation of the line, isn't it? At the point t, because t is a point on this line, and this line here is given by this vector equation. So which means that if I have that position vector for t, that position vector of t will satisfy this one here, meaning where there is r, we are supposed to put the position vector of t. So it means we shall have this as negative 4, negative 1, 1, plus lambda into 2, 3, and 3. So, but this is same as having negative 4 plus 2 lambda, negative 1 plus 3 lambda, and then 1 plus 3 lambda. So what we are getting here is now equaling to the position vector for t. I hope that one is okay. Now, this is the position vector of t. But can we say that b to t, the vector b to t, is perpendicular to this line? Yes?
Yes.
Is perpendicular to this line. But if it is perpendicular to this line, it is also perpendicular to this one, to this vector here.
So you're saying BT is perpendicular to B?
B to T is perpendicular. This vector here, B to T, is making 90 degrees with this line.
Yeah.
Isn't it?
Yes,
but if it makes 90 degrees with this line, then it means it also makes 90 degrees with what? With the B.
Next line.
With the B. With the vector B. Because the vector B is in the same direction as the line.
Yes.
So
assuming that you prolong the vector BT.
Yes.
If you prolong it to B, it will be perpendicular.
Exactly. Yes. It will be perpendicular also to this. So this one here is the direction vector in the same direction as that one of the line. So that's why we say that if the moment this is perpendicular to this line, then it is already perpendicular to what? To the direction vector. So can we now say that this BT is perpendicular to the line?
Yes.
Is perpendicular to the line. But the fact that is perpendicular to the line, it makes it also to be perpendicular to the what? It is also perpendicular to vector. Is also perpendicular to vector B. Now, if that one is true, then can we say that this implies that when you get BT, okay, you dot it with vector B, you will get a 0?
Yes.
But now, if you have this dot this equaling to 0, what is B to T? What is BT? BT is same as OT minus OB.
OB.
But OT is given by this one here. Because this is T, and which is representing OT. This is the position vector of T, which means OT is same as this. Now, where there is OT, we shall put there -4 plus 2 lambda, -1 plus 3 lambda, and 1 plus 3 lambda. Then we shall subtract OB. What is OB? What is B? B is this point here, 1, 1, 3. Okay?
Yes.
So that is 1, 1, 3. And this will give us, let's get that.
-5
-5
plus 2 lambda.
plus 2 lambda,
-2
-2
plus 3 lambda.
plus 3 lambda,
Yeah. -2
-2 again,
plus 3 lambda.
plus 3 lambda. So this will be our BT. So if BT is equal to that, BT is equal to that, then this will imply that from this given fact here, that BT dot B is equal to 0, then we can say this implies that from star, when we have -5 plus 2 lambda, -2 plus 3 lambda, -2 plus 3 lambda, when we dot this one with B, we shall be able to get 0. But again, what is vector B? What is vector B?
1, 1, 3.
Is it
Just check.
vector B?
I can't remember well. It's like it was 1, 1, 3.
Oh, that was the point B. Vector B. Vector B is this one.
Oh, yeah.
The direction vector. So what is that vector equaling to? What is this vector equaling to? Huh? How do we get the direction vector from the line, from the equation of the line? Don't tell me you have already forgotten.
You get it is 2, 3, 3.
It is 2, 3, 3. This one here, which is down here. 2, 3, 3. Provided the coefficients for x, y, and z is
1.
Is 1. As simple as that. So this is 2, 3, 3. So that is the one we shall dot with here. So this is dot 2, 3, 3. And this must give us what?
0.
Must give us 0. Now let us dot that one. This will be negative, let us have it as 2 into -5 plus 2 lambda plus 3 into -2 plus 3 lambda plus 3 into -2 plus 3 lambda, which will give us 0. This will be -10 plus 4 lambda, -6 plus 9 lambda, -6 plus 9 lambda, which is equal to 0. So this is -10. Get this and this. That is -20. -22.
Yeah.
Then 4 lambda, 13, 22. Plus 22 lambda is equal to 0. So 22 lambda is equal to -22. Lambda becomes, is it negative,
Negative 1.
positive? This is should be positive, I think. This one goes the other side. So lambda is positive. Lambda is positive 1. So you'll be able to get the value for lambda there. But after getting the value of lambda, what is your interest? Your interest is to get this distance from B to where? To T. This is the perpendicular distance we are talking about. The distance from B to T. That is the perpendicular distance. Okay? So what is that one there? As I said, to get that distance, you must first of all know the vector BT. So what is vector BT? Vector BT is this. So we need to come back here and get BT. So let me put this line here. So what is BT? BT is this. Now we shall substitute for lambda in BT. So let us substitute for lambda to get vector BT. So for vector BT equaling to, so vector BT will be equaling to, let us get that, negative 5 plus 2 into 1, negative 2 plus 3 into 1, negative 2 plus 3 into 1. So vector BT will be same as
Negative 3.
negative 3,
1.
1, 1. So this is vector BT. But still, what is our interest? Our interest is to get this distance. And how do you get distance? By taking the magnitude or modulus of vector B to T. This is our T, this one here. So that is where we have T. So we are interested in the distance. So what does that imply? This implies that distance D is same as magnitude of vector BT. And that will be same as taking the square root, negative 3 squared plus 1 squared plus 1 squared. So D will be the square root of 9 plus 1 plus 1, that is 11. So this implies that the required distance, therefore the required distance is square root of 11 units. And that will be the answer. So I hope the procedures are okay. So the procedures are, you have your point here. You need the distance from this point to this line. So on this line, what do you need? You need to know what is the parallel vector to this line. And if the parallel vector is given, or the line is given, you can extract out the parallel vector. Then if B meets, if this perpendicular line segment from B meets this line, it can meet it at any given point, which you can call T or any other point. Then your interest will be to show that this B to T is perpendicular to B, and with that it will help you to get the value of lambda, which you will substitute in BT to get the answer. So that is basically what we consider. Can we move on? Now, let us look at the next question. Can we get to the next question?
Yes.
Okay, so the next question says find the shortest distance of the point P, which is 2, negative 1. Find the shortest distance of the point that from the line whose equation is x minus 2 over 1, y minus 1 over 1, z plus 3 over 2. We need to look at that. Whenever they talk about the shortest distance, they are meaning the perpendicular distance. So that is the same method we shall use. Now let us consider this line here. So this is our line. Which line is given by this? But this line has got a parallel vector. That is a vector that is parallel to that line. So that is our parallel vector B. This is our line. Now from that, we need to get the distance from a point. Our point is point P, which is 1, 2, negative 1. So we want this distance from this point to this line. And we are saying that suppose the line from P to this line here meets this line at a particular point, T. So we are letting this point T to be the point from which the perpendicular line segment from point P meets this line. But of course, we must know what is B. What is V? What is B for that case?
B is 1, 1, 2.
B is 1,
1, 2.
1, 2. Okay. So we are interested in this distance, which we can call D. So as usual, we can first of all express. Let us first express. Let us first express we express the line equation. Let us first express the line equation in the vector form. So what will it be? What will this one be? It will be R equaling to
2, 1, negative 3.
It will be 2, 1, and negative 3 plus
lambda. Lambda into
1,
1, 2.
1, 1, 2. Now, that is what we need. So we shall have our R as 2, 1, negative 3 plus lambda 1, 1, and 2. Next, we know that this point T, which we have put on our line here, this is a point from which the perpendicular from P meets the line. So that point T, the fact that it is on the line, it means it will satisfy the equation of the line. So we are saying T is a point at which the perpendicular from point P meets the line. So what does that imply? It implies that at that point T, it means its position vector will be satisfying this equation of the line. Okay? Will be satisfying that equation. That is what it implies. Now, from there, let us go on. Since we have got T, our interest is to get P to T, because the distance which we need is the distance which is the modulus of PT. That is what we need. So we can first of all still go on and have this one as in simplified form. That is 2 plus lambda, 1 plus lambda, negative 3 plus 2 lambda. That is what we shall have. Now from there, let us now again move on and see how best we can get P to T, because that is our interest. So what will be P to T? P to T, we need that. And also, we must know that this vector P to T is perpendicular to the line. And if it is perpendicular to the line, it is also perpendicular to the direction vector. Okay? So we shall also use that. We know that since PT is perpendicular to the line, is perpendicular to the line, then it must also be, it is also perpendicular to the parallel vector B. Because if P to T is the vector that is perpendicular to this line here, then it must also be perpendicular to this direction vector. Now, that will give us the expression that if PT is perpendicular, then this implies that when you get vector PT, you dot it with B, you get a what? You get a 0. But for PT, vector PT is same as OT minus OP. So what is OT? OT is this vector. Vector T represents the position vector of O to T. So we shall have 2 plus lambda, 1 plus lambda, negative 3 plus 2 lambda. This one here, we are subtracting OP. What is OP? That is vector P. And the OP is 1, 2, and
1 to negative 1.
1, 2, negative 1. And this will give us 2 minus 1 plus lambda, 1 plus
1 plus lambda.
Then this will give us negative 1 plus lambda. And this last one will give us
negative 4 plus lambda, 2 lambda.
Negative? That is negative 2.
Negative 2
Plus 2 lambda.
Plus 2 lambda.
So we know that this is the fact that PT dot B will give us 0. Since we have PT and we have B, let us now substitute. So from this equation star, can we have this as PT 1 plus lambda, negative 1 plus lambda, negative 2 plus 2 lambda. This one here, we dot it with B. What was our parallel vector? That was it, 1, 1, 2. 1, 1, 2. So we shall dot this with 1, 1, 2. So this should be able to give us a 0. So let us go on and multiply 1 plus lambda times 1. It remains 1 plus lambda. So we shall add there. This times 1, it remains negative 1 plus lambda. This times 2, it becomes minus 4 plus 4 lambda, which is equal to 0. So let us try to simplify this. What shall we have? Lambda, 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 6 lambda. We are adding there 1 minus 1. So we shall remain with minus 4, which is equal to 0. So 6 lambda is equal to 4, giving us lambda as 4 over 6, which is 2 by 3. So therefore, lambda is same as 2 divided by 3. So we shall be able to get the value for lambda. Now, after getting the value for lambda, still our interest is not necessarily getting lambda only. Our interest is to get this distance from P to T, and that distance is D, and that distance is same as having magnitude of PT. So our interest is to go on and get P to T. So P to T is this. That is what we shall substitute for. So let us again refer to PT. So for PT, which is equal to we had that as the 1 plus lambda, negative 1 plus lambda. Then the last one was negative 2 plus 2 lambda. So the next one was negative 2 plus 2 lambda. So this is our PT. But our lambda is 2 divided by what? Our lambda is 2 divided by 3. So let us substitute such that we get PT as 1 plus 2 divided by 3, negative 1 plus 2 divided by 3, negative 2 plus 2 times 2 over 3. So this will give us, so get the LCM 3 times that will give us 3 plus 2, that is 5 over 3. Negative 3 plus 2, negative 1 over 3. This is negative 6 plus 4, that is negative 2 over 3. I hope that is okay. You get LCM, that is same as getting the LCM there. So you are having 1 plus 2 over 3, so get the LCM. That will be 3 plus 2, which is 5 by 3. So you are simply adding the 2, which I think you can do. So this will be same as having, can we pull out a third? If we pull out a third, what remains here? If I pull out this 1 over 3, here you remain with? What do we remain with there? Man, are you there? What do we remain with? We are pulling out a third. So we shall remain with this one as 5, negative 1, and negative 2. So that is our PT. So after getting PT, we need to go on. We need to go on and obtain. We need to go on and obtain the distance for PT. So what will be the distance PT? So let us say for the required distance, D is the same as magnitude of PT. So D will be same as, let us get this one here. For this one, this is a scalar, so simply maintain a third out and take the square root of each of these. That is 5 squared plus negative 1 squared plus negative 2 squared. So this will be a third. Then this will be the square root of 25 plus 1, 26 plus 4, which will be 30. So this implies that D is same as 1 out of 3 square root of 30 units. So that will be the required distance. That will be the required distance for the point P. For the point P from the line. And that is how we shall obtain that distance there. Is that one very okay?